Welcome to this OST2 lecture about the endorsement hierarchy and the endorsement key in TPM 2.0. We learned about the TPM hierarchies in TC 1101, and in the first course we used mostly the owner hierarchy. In most use cases, this is the TPM hierarchy that fits the use case. We have control over that hierarchy, and we can create as many key hierarchies as we need. Our TPM key hierarchy is established by creating a new primary key, and then we can generate as many child keys under that primary key, as shown on the picture here in the right. At the same time, the use cases surrounding machine identity require us to use the endorsement hierarchy. In this lecture, we will learn how and why the endorsement hierarchy is special, what are its properties, and how can we make use of it. The endorsement hierarchy is special because the TPM vendors and the OEM manufacturer can insert different objects inside the TPM at manufacturing time that can help us authenticate if a TPM is genuine. And this is a very long topic, so here we'll focus on the important details and we'll look how to approach this problem in a practical way. Because the topic is complex, we're covering it in more than one lecture. Now, we need high guarantees to be able to establish an identity in our system and throughout our systems. For this, we need to establish some kind of a correlation between the identity of the TPM and our machine identity that we need to create. This is possible because if we use the same endorsement seed, we can generate the same primary key. And if we follow the TCG specifications, we can establish a reproducible identity that is bound to the TPM. And by verifying the TPM is authentic, we can then establish that the identity is authentic. Of course, when we talk about identity and identification, immediately privacy concerns arise. We have seen that even with the new regulations that have taken place in the European Union, like GDPR. For your application, there might be privacy concerns. So when using the endorsement hierarchy, we have to keep that in mind. And of course, there are direct solutions, but again, depend on your use case, especially for business-to-business interactions and enterprise software solutions and enterprise security solutions, the privacy concerns can be covered in the contract, so the technology doesn't have to be limited. The straightforward solution when we have privacy concerns with the TPM is to disable the endorsement hierarchy, thus preventing anyone from establishing a link between the TPM that is soldered on our laptop or between the TPM in our data center and the identity of the machine. So the machine, in essence, cannot be identified using the TPM bound identity. Now, we still have the option to use the owner hierarchy and create a primary key, a signing key that we can use to create digital signatures and this way establishing identity. But we are then missing the benefits of using a TPM bound identity to the endorsement hierarchy. The bottom line is that in most use cases, especially business to business, the privacy concerns related to the endorsement hierarchy are not valid. In case such privacy concerns exist, consider disabling the endorsement hierarchy or just use the owner hierarchy to establish identity for your operations and your systems. Now, the endorsement hierarchy has more than one use case. First, we mentioned the objects that can come from the TPM manufacturer or for the platform vendor that we can use to verify the whole platform and the TPM authenticity. From there, we'll generate a primary TPM key following the TCG specifications under the endorsement hierarchy, and this key will be called the endorsement key. From there, we can establish the machine identity. And even further, we can use the endorsement hierarchy for other purposes by creating child keys under a primary key under the endorsement hierarchy. It's not necessarily that to be the endorsement key. The importance of the endorsement hierarchy is that the endorsement seed is randomly generated at manufacturing time and does not change for the lifetime of the device. What are the typical objects that live inside the TPM from the manufacturer? As just mentioned, of course, we have the endorsement seed. From there, following the TCG specification, we can create an endorsement key that's compliant with the TCG template. And from there, we can use the EK certificate to verify the chain of trust going all the way back to the TPM vendor. The EK certificate contains a public key and link to the intermediate certificate of the TPM manufacturer. We will learn how to verify a TPM using the EK certificate in a following lecture. To generate machine identity using the EK, we need to take several steps. First, we need to generate the endorsement key. And in order to be able to verify the TPM authenticity, we would have to follow the TCG templates. For every TCG template for an EK, there has to be a separate EK certificate. We'll talk more about that in the next lecture when we see the practical steps to verify a TPM. Now, the default EK templates in most cases are available and stored at the non-volatile memory of the TPM itself. Usually we have at least one for RSA and one for ECC. Because the endorsement key template by the TCG does not allow the use of the sign flag that enables signing operations and the creation of digital signatures, to verify and link the machine identity to create it, we would have to generate a child key, prepare a challenge, respond to that challenge, and thus establish a link that only the EK that created the challenge can then decrypt and match the challenge. We will learn about the details of this procedure in the next lecture. Here, we are providing the fundamental knowledge about the endorsement hierarchy and the EK. In case we need to perform signing operations with keys under the endorsement hierarchy, we have two main options. First, create our own primary key under the endorsement hierarchy that does not follow the TCG templates. Or, still use the TCG templates, create the EK, and then generate a child key for signing. Depending on the use case, one of these solutions will always work. To generate a key under the endorsement hierarchy, of course, we have to provide the proper authorization. And if we use the TCG templates, depending on the template we've chosen, we might also need to provide policy authorization. And as a quick refresher, there are in general three types how we perform TPM authorizations of objects. There is a password authorization, which is set by the user without flag when creating different keys. And this is how we created the keys in the first labs in this course. Also, throughout TC 1101, we used password authorization, but of course, using it with the TPM tools was somewhat more straightforward. Here, we need to make sure that we set that user without flag using ESAPI. Then we have HMAC authorization, which offers us a bit stronger authorization, and at the same time, it is similar to a password. We just have a hash-based message that can also satisfy the password requirement. And last, and very important, we have policy authorization, which is part of the enhanced TPM authorization that we'll learn about in this course.